Fritz Stichweh Maschinenfabrik proudly presents their range of drag scrapers for various applications in sand and gravel excavation. First, we shall give you a detailed account of the specific construction of this plant, the KS600, with hydraulic walking equipment. Let's start at the top left. The in-haul rope is guided over two head sheaves which are arranged to allow the rope to be guided to the rope drum outside the hopper. The outhaul rope leads via the outhaul pulley to the return pulley on the floating tail sheave station and to the scraper bucket. The float is anchored via a warping winch which is attached to the bank, thereby allowing easy maneuvering of the floating tail sheave station. As mentioned, the rope is guided to the scraper bucket over the return pulley. The in-haul rope on the bucket is then guided via the return pulleys on the scraper bucket back to the cable winch. The bucket has a capacity of 7 cubic meters and is equipped with lateral wearing skids which, depending on the type of excavation goods in the pit, may be made of various materials including cast steel. The rear end of the bucket has a movable flap which is also provided with a blade of wear-resistant steel. This movable flap ensures that the bucket does not take dredged material back into the water. Above the scraper bucket runs a lifting rope connecting the outhaul and in-haul chains and ensuring that the respective passive rope does not drag in the dirt. For ongoing transportation of material, the plant is equipped with a receiving hopper and a vibrating coarse-size grizzly. The vibrating device screens out oversized stones from 150 millimeters. The material smaller than 150 millimeters passes through the grate bars into the hopper. The oversized material is eliminated via a lateral chute. Now let's look at the arrangement on the lower left of the plant. The reciprocating feeder distributes the material in the hopper continuously to the dewatering screen. An electronic volume controller guarantees that the feeder is stopped and cut off in the event of material overflowing. Under the dewatering screen lies the receiving trough for the fine-grain material. The dewatering screen is provided with double elastic bearings to reduce vibrations. Here the first bearing between the screen frame and the base, and a further damper on the base as well. The well-dewatered screenings pass via a short transfer belt to the conveyor belts leading to the preparation plant. The transfer belt can be adjusted by chain action to center it over the optimum transfer point. Now we'll take a look at the core of the plant at bottom right. This is where the two-drum scraper winch is accommodated. Left, the drum for the in-haul rope, in the middle, the clutch, and right, the drum for the out-haul rope. Both drums are connected to the main drive unit via the clutch. For a better view of the mechanism, the cover has been removed. The cam ring serves to measure the speed of the winch and the drag bucket's distance. The whole plant is pneumatically controlled. All actions are connected in parallel, that is, when the in-haul drum is engaged, the out-haul drum is automatically braked. When the out-haul drum pulls, the in-haul drum is braked in turn. This prevents the cables from hanging slack and avoids unnecessary wear and tear. When the counterweight of the brake cylinder falls, the winch brakes are applied. The system is powered by an air-cooled 12-cylinder Deutz diesel engine with a torque converter which can raise the torque to 2.5 times the load factor. And now to the final position, the operator's control panel in the cabin. The cabin is well raised and generously proportioned, allowing the operator excellent all-round visibility. Single lever control for all main operations. The central position is off. Pushed to the left or right, the bucket is hauled in or travelled out respectively. The more the lever is tilted, the greater the engine power applied. The bucket's limit of travel is set by sensors to prevent the chain being drawn into the sheaves. On the right of the control panel are all the instruments for monitoring the direct scraper actions. On the left are the switches and pilot lamps for the various auxiliary units, such as the dewatering screen and conveyor belt, etc. An LED display provides status data on distances and functions. Stichweh scrapers are the product of 40 years of continuous development and experience. Their sophisticated design concept makes them eminently suitable for rationalized and perfected sand and gravel excavation. By showing you several more examples of the Stichweh range of drag scrapers, we aim to provide you with comprehensive information on how to make the most of their modular design principle for various applications in sand and gravel pit operation. This is a drag scraper type KS400 with crawler gear in operation. It is equipped with a receiving hopper and vibration grizzly. The vibration grizzly has to be switched on while the bucket is ascending the ramp to ensure that accompanying stones are eliminated straight away and do not become lodged. The bearings of the vibration grizzly are externally mounted. Vibration damping is effected by silent rubber blocks. The oversize, which is separated by the grizzlies, falls back onto the ground via the oversize chute and is cleared as required by a loader. The reciprocating feeder guarantees even spreading on the conveyor belt. By altering the pendants and the weights, the feed volume and thus the belt loading can be changed with great precision. When feeding sand, the pendants open less than when feeding larger stones. It's a simple but highly effective system. Only the scraper principle allows giant stones to be landed unproblematically. Even erratic blocks, larger in size than the bucket itself and weighing up to 10 tons, are pushed along effortlessly. Another view which proves that the reciprocating feeder guarantees even charging of the overland conveyor belt on the way to the Stichweh preparation plant. A type KS400 drag scraper in dry excavating operations. The trucks can be loaded straight from the hopper. The excavation site is so far from the preparation plant that vehicle shuttle transport pays off. This excavation site is a 20-meter-high vertical working face. With a longer boom, up to 30 meters deposits can be excavated in a single cut. The only component that moves within the collapsing zone of the face is the bucket. The scraper and boom are outside the hazard zone. The operating personnel and the plant itself are never endangered during the excavating operations. In comparison with other, often breakneck systems, this one provides a maximum of operational safety. In addition, this excavation site demands several cuts, meaning that all the ensuing plants, such as conveyor belts, etc., would have to be relocated to conform to the current cutting situation. The composition of this deposit ruled out the occurrence of large stones from the outset, so a vibrating grizzly was not required. At the rear of the bucket, two blades can be extended for the purpose of rending the face and causing it to slip. One of them can be clearly seen here. The feeding hopper has a hydraulic stopper, enabling the hopper to buffer several bucketfuls before opening to load a dump truck in a matter of seconds. With its crawler gear, the plant can easily be moved to a new site. Once again, a Stichweh drag scraper proves its superiority in safe and rationalized dry excavation of vertical faces. This KS400RA also makes use of a boom and crawler gear. The unit is designed for shallow excavation depths down to 10 or 12 meters. The plant is equipped with a hopper and a vibration grizzly. It also features a horizontal vibration screen for separating stones larger than 32 millimeters. The reciprocating feeder again effects even feed to the screen, which is provided with durable plastic elements for extremely long service life. From his raised cab with good views in all directions, the operator controls the travel out of the 4 cubic meter bucket. The boom is 30 meters long. Here too, the Stichweh drag scraper proves its superiority in excavating flooded gravel deposits. The conveyor belt carries the 0 to 32 millimeter screenings to the gravel stockpile. At this shallow excavation depth, the crawler vehicle can easily be relocated. A 4 cubic meter bucket is drawn out of the water and stops for a moment to allow the surplus water to drain off. Then it is hauled up the ramp of the type KS400R drag scraper. R stands for crawler gear. Here the truck is loaded straight from the scraper, so this plant is equipped with a hopper for direct lorry loading. The scraper operator himself takes the lorry straight to the gravel stockpile. Before driving off, he leaves a full bucket to drain on the ramp. In a further lorry loading scenario, the driver makes a small stockpile close to the ramp for rapid loading onto the lorry. On the opposite bank, the tail sheave for the outhaul rope is positioned and anchored in the ground. In the space of 2 to 3 minutes, the scraper driver has loaded the lorry with 3 bucketfuls. Proof positive of the efficiency of this scraping plant. Next to the Stichweh drag scraper stands a dragline excavator from the old days of gravel excavation by this uneconomical working method. This drag scraper type KS 600 SH is operating under very difficult conditions. The material is on a vertical face and is undercut by the drag bucket and made to collapse. It is very coarse material interspersed with a lot of dirt, an almost impossible task for other types of scraper to accomplish. This drag scraper is also equipped for feeding the material onto an overland conveyor belt. It is powered by an electric motor. The lateral oversize chute for eliminating unwanted large stones. The feeder belt is linked directly to the scraper unit so that the feed point for the conveyor can be optimally positioned. An impressive aerial view of the whole installation with the drag scraper and the preparation plant. This drag scraper plant was built about 20 years ago and sometimes operated in 3 shifts round the clock. The entire pit area was exploited to a depth of 15 meters. Despite its considerable age, this plant is still performing its daily duties. The material is mainly very fine and sandy. It is transported by conveyor belts to the Stichweh preparation plant. This plant, on the other hand, belongs to the latest generation of drag scrapers. It is a type KS 600 SH equipped with a 7 cubic meter bucket. The material being excavated here to a depth of 20 meters is also very sandy. The outhaul rope is now guided over 2 head sheaves arranged so that the cable runs outside the hopper to the cable drum. The slewable feeder belt is supported by chains and can be moved by a hand winch into the optimum position for charging the overland belt. The float for the return pulley, also housing the two warping winches, therefore forms a very compact unit. Only the anchorage of the float is still located on the opposite bank. This is an ideal solution for extensive areas of water and when the opposite bank is not available for large support facilities. Maneuvering is directed by radio link from the cab of the scraper plant. The entire electrical installations of the plant are housed in this circuit cabinet. It also houses the modules for the so-called compact programmed control unit. This principle enables various operations to be controlled from the cab via this electronic system working at 24 volts. The grizzly, the feeder motor and the dewatering unit can be controlled from here, either manually or in automatic mode. The reciprocating feeder again. The electronic control switches it on and off and opens and closes the pendants as the material flow requires. The wastewater from the dewatering stream either flows back into the pond or, as required, can be channeled back down the scraper ramp. This circulation effects a forced separation of the fines. There now follows an explanation of drag scraping operations in automatic mode, demonstrated on a Type KS 400. The head sheave as well as the outhaul pulley are equipped with pressure cells for measuring an overload for feedback to the automatic operating system. The operator keys in the bucket distance values, and if the rope is subject to greater tension, for example from a large stone, the automatic cutout is applied and a signal given. The various switch points for the bucket as well as the optimum dwell time for bucket dewatering are programmed into the control unit. Control of the bucket in the dead-end position is effected by two ultrasonic sensors. The additional emergency cutout switch is integrated into the cable drum's clutch mechanism. The display shows the current position of the bucket. The scraping tracks and speeds input via the keypad can also be read off. The automation controls the operation of the following stations: twin drum scraper winch, hopper, grizzly, feeder, dewatering screen, etc. At any time, by switching to manual mode, the automatic scraping operation can be interrupted. The complete electronics for automatic mode are housed under this console in the cab. The operator's only manual task is to refuel the plant when necessary. Before the drag scraper was installed, the pit could only be excavated down to a shallow depth of 6 meters with this dragline excavator. The Stichweh drag scraper allows exploitation down to much greater depths. In the vicinity of Bad Breisig stands this drag scraper Type KS 400 SH. Like many others, this plant is also equipped with a slewing feeder belt. In this case, it is slewed by hand. The purpose of this installation, as already pointed out, is to align the feeder to the best position for charging the overland conveyor. That is, the hydraulic walking equipment locates the drag scraper optimally and the transfer point is fixed. The alternative method, Should any of the downstream stations in the preparation plant fail, the feeder can be slewed aside from the overland belt to make a new stockpile next to it. This can then be cleared by loaders during the stoppage. In this way, the excavation operation need not be interrupted. When the fault has been rectified, the feeder is slewed back to the original position and production continues as before. Here's the dewatering screen with the reciprocating feeder again. Depending on the material and the required throughput, the size of the screen and its apertures, and the dwell time of the material on the screen can all be harmonized to attain the lowest and most economical residual water content. Fine sand, washed out with the wastewater, is fed back into the scraper track. The in-haul drum is equipped with cable grooves on the patent Le Bus system, ensuring clean winding and hence long service life. This plant is powered by an electric motor. The infinitely variable torque converter allows optimum rev control. As already mentioned, the entire plant is pneumatically controlled. Once again, here's the standard torque converter. With the aid of pneumatically operated guide blade regulation, the scraping speed can be finely adjusted also in electrically powered plants, even though the motor runs at constant revs. Irrespective of whether the plant is operated manually or in automatic mode, Stichweh drag scrapers can today make additional use of electronic control and system optimization at all relevant stations throughout the excavation process. Stichweh drag scraping plants have been in operation round the globe for decades. Because of their robust and sophisticated engineering, they are reliable and economical excavators both for underwater and dry operation. They are a match for any other systems and frequently superior to them. We shall continue to support the sand and gravel industry by word and deed and with our innovative potential in the years to come. Thank you for your kind attention.